Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. Up to now, we've been studying trigonometry in the context of triangles, using side ratios and angles to solve problems. But trigonometry doesn't just stop there. To go further, we need to extend these ideas beyond triangles into the coordinate plane, where angles can rotate freely in a circle. That is where standard position comes in. So in today's video, we'll cover what a standard position is and how to work with this idea efficiently. So on the screen here, we have the x and y axis that you're familiar with. Now an angle is said to be in standard position if its vertex is at the origin, its initial side lies along the positive x-axis, so meaning on this side, and its terminal side is rotated from there, so meaning we can either go this way or we can go this way. But in both cases, we're rotating from the positive x-axis. So if we go counterclockwise, these angles are positive angles. And if we go clockwise, then we're going to have negative angles. And wherever we stop, that is called the terminal arm. So the angle is the angle that is formed between the terminal arm and the positive x-axis. On the screen here, you'll notice that we have some degrees already written down. Along the positive x-axis, the first one is 0 degrees, and that is because that is our starting point. And you'll also notice that there's 360 degrees beside it, and that's because we know that if we rotate one full circle, that is going to be 360 degrees. And the rest of these angles are just ways of dividing 360. So if we rotate all the way to the negative x-axis, that is going to be half of 360, which is why it is 180 degrees. You're probably familiar with all these angles in degrees, but from now on, you need to be familiar with the angles in radians as well. So let's go ahead and write those down. 0 degrees is going to be 0 radians. A full 360 degrees is 2 pi. So that tells us 180 degrees is going to be pi because pi is half of 2 pi. And the positive y-axis, that is going to be pi over 2. Which means the negative y-axis is going to be 3 pi over 2. You should know these values by heart because we will be using them a lot, and it'll save you a lot of time if you remember them instead of trying to convert between radians and degrees all the time. So now let's take a look at a few examples. We want to draw the following angles in standard position. So the first angle here is 150 degrees, and it's positive, which means we're going to start from the x-axis and we're going to go counterclockwise. So when we hit the positive y-axis, that is 90 degrees, and then we're going to go 60 degrees more, so it'll end up somewhere around here. So that means our terminal arm is going to be somewhere around here. So this would be 150 degrees. Our next angle is negative 270 degrees. So because it's negative, we're going clockwise from our positive x-axis. So we're going to go 90 degrees, 180 degrees, and then 270 degrees will be up here. So that means our terminal arm is going to be right on the positive y-axis, and that is negative 270 degrees. The third angle is in radians. It is pi over 3. So try not to convert this to degrees. Think of pi over 3 as 1/3 of pi. We start with 0, and then on the other side, the negative x-axis, that is pi. So pi over 3 is just going to be 1/3 of that, which means it's going to be somewhere here. So this would be pi over 3. Our next angle here is pi, and that's one of the ones that we should remember. So we know that is half of a full circle, so it goes to the negative x-axis. So that is pi. So our terminal arm is right on the negative x-axis. Our fifth one is negative 5 pi over 6. So again, because it's negative, we're going to go clockwise. And we're going 5/6 of the way to pi. So that is going to be somewhere around here. So our angle right over here is negative 5 pi over 6. And our last angle is 7 pi over 3. So notice that 7 pi over 3 is 2 pi plus pi over 3. We know that 2 pi is one full circle, so that means it's going to go a full circle first, and then another pi over 3. So this is going to be our 7 pi over 3. Some of you astute viewers might have noticed from the last example that 7 pi over 3 ended at the exact point as just pi over 3. And that is what we want to address here. So these are actually called coterminal angles. Coterminal angles are when two angles share the same initial and terminal sides, but they might have different rotations. So to find coterminal angles, we simply add or subtract full rotations. So in radians, we would be subtracting or adding 2 pi. And in degrees, it would be 360 degrees. Next, let's go ahead and define what reference angles are. A reference angle is the acute angle formed between the terminal side of your angle and the x-axis. And the reference angle is always going to be positive, even if your angle in standard position is negative. So let's see what we mean by that through a couple of examples. For our first example, we want to find two coterminal angles to pi over 4. So let's go ahead and draw that. So we know that pi over 4 is going to be right over here. So in order to find a coterminal angle to pi over 4, what we can do is we can go one full rotation and then stop at pi over 4. What that's going to give us is pi over 4 plus 2 pi, because one full rotation is 2 pi. So that means our agreeing angle is going to be 9 pi over 4. To find another one, we can simply go 2 full rotations and then stop at pi over 4. But we can also go in the opposite direction. So if we go clockwise and then stop at pi over 4, what that means is this would be as if we started at pi over 4 and then went clockwise for a full rotation. So that would be pi over 4 minus 2 pi. And this tells us that our red angle would be negative 7 pi over 4. Next, let's take a look at how to find reference angles. So for our first question, we want to find the reference angle for 5 pi over 6. So let's go ahead and draw that angle first. 5 pi over 6 is going to be somewhere here. So that is our angle in standard position. Now the reference angle is always the acute angle formed by our terminal arm, which is this one here, and the x-axis. So the acute angle will have to be formed by the negative x-axis, because if we pick the positive x-axis, that would be more than 90 degrees. So that means our reference angle is this angle right over here. And we're going to call that theta with a subscript r. Theta r is going to be equal to pi minus 5 pi over 6. And the reason is because we know that it is pi here, so which means our theta r plus 5 pi over 6 is going to add up to pi. So therefore, the reference angle for this one is just pi over 6. Let's go ahead and draw our next angle. So our angle in standard position is 7 pi over 4. Now 7 pi over 4 is going to be down here. So this is our angle in standard position, which is 7 pi over 4. Now our reference angle is the angle formed by this terminal arm and the x-axis, such that the angle is going to be acute. So in this case, it will be with the positive x-axis. So our reference angle is this one right over here. And to calculate it, we know that if we go one full rotation, this would be 2 pi. So that means 7 pi over 4 plus our reference angle is going to give us 2 pi. So now solving for the reference angle, we get this is equal to 2 pi minus 7 pi over 4, which is equal to pi over 4. So notice how for the reference angle, it's always positive. We don't care about whether we're rotating clockwise or counterclockwise. It's just the absolute value of the angle that we care about. Make sure you take the time you need to understand reference angles and how to calculate them, because it is one of the most important concepts that will tie the trigonometry you've learned in the past to these rotating angles in the circle. The last concept that we're going to cover in this video are quadrants. So we know that if we have our x and y axis, it divides the plane into 4 quadrants. And they're labeled as 1, 2, 3, 4, starting with the quadrant with positive x and y values. So this would be 1, that would be 2, this here is 3, and this one here is 4. So looking at this first angle that we've drawn on the screen, we have, this is our angle theta, and it's in quadrant 2. We know that in quadrant 2, our x values are going to be negative, and our y values are going to be positive. Now the r here is just our hypotenuse, and the hypotenuse is always going to be positive. So what information does this give us? If we take a look at the trig ratios for this particular quadrant, we'll see that sine theta is going to be equal to opposite over hypotenuse, which is y over r. And that is going to be a positive number over a positive number. So that means sine is going to be positive. If we take a look at cosine theta, that is going to be adjacent over hypotenuse, which is going to be x over r. But since x is negative, that tells us that we're going to end up with a negative number. And then the last trig ratio is going to be tangent theta, which is going to be opposite over adjacent. So that's going to be a positive over a negative number, which means that we're going to end up with a negative number. So that tells us in quadrant 2, only sine theta is going to be positive. So let's go ahead and label that with an S. And if you do the same sort of calculation, you'll see that in quadrant 1, everything's going to be positive. In other words, all of them. So we'll label that as A. In quadrant 3, only tangent is positive. So we'll label that T. And in quadrant 4, only cosine is positive. So we label that C. And an easy acronym to remember that is all students take calculus. So now using that information, let's take a look at our previous example where we had our angle as 7 pi over 4. So that tells us that sine of 7 pi over 4 is going to be a negative number because we are in quadrant 4 where only cosine is positive. So sine is going to be negative, and then cosine of 7 pi over 4 is going to be positive. And tangent of 7 pi over 4 is also going to be negative. At this point, we don't know what the values are, but we will work towards that once we have an understanding of special triangles. And now let's go ahead and do a quick recap of everything that we covered here. We went over how to draw angles in standard position and how to find coterminal angles. We also learned how to find the reference angle, which is a very important point that we're going to be using throughout this unit. And lastly, we learned how to use the quadrants and how they affect the signage of each trig ratio. These are your basic building blocks for this trig unit. So make sure to spend some time to get comfortable with these ideas because we will be referencing them a lot in the future videos. And now it is your turn to give this a try. Can you find the solution to these 4 problems on the screen here? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on trig in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.